Hey, it's our Fingerlines Math Industry, and we are going to take a look at the diagonals of a polygon. So in the last video, this last video, we've been taking a look at all the different names of the shapes and also how they relate to the number of sides. We also looked at how many degrees is in the interior part of the shape. And we also learned that the ratio is 1 to 180 degrees because every time the number of sides went up by 1, the number of degrees, that's the sum of interiors, is 180 degrees more. But now we're going to take a look at the diagonals of a polygon. So we're still going to talk about the inside of it. The other thing is, instead of looking at angles, we're going to look at the diagonals. So let's get started. So what looks like here is a hexagon. We have 1, 2, 3, 4, 5, 6 sides. Therefore, on the name chart, we have a hexagon. So the question is, what are diagonals? Well, when you think about diagonal line, it kind of makes sense that it's going to look like a slope like this. And it doesn't make sense that it's going to happen. So let's get started. Diagonals are going to be lines that go across from each other, but does not count as the sides that are next to each other. For example, these points, we are going to number them. Actually, we are going to letter them. So A, B, C, D, E, F. So, for example, FA, FB, and FC can be an example of a diagonals. FE, FE, and FD are not because they are they're making a side and they're also right next to each other. So diagonals happen when there are lines that go across the shape. However, they cannot be next to the point that's connecting with. So let's see how many times we can do this without repeating or without doing any math. So we have that. We have from D to E, D to A, and D to B. So then, we already have C to F because that's connected. So the only option is we have C to E and C to A. So for B, we already have B to F, but we can do B to E, and we already have B to D. For A, we already have A to F, A to D, and A to C, and for E, we already have E to B, E to C, and E to D. So let's calculate that. So for the green only, we have 3 diagonals. For the orange, we have 3 diagonals. For red, we have 2 diagonals, referring to the photo. So 3 green, 3 orange, 2 red, and for purple, we have 1. If we add all of them up, 3 plus 3 is 6 plus 2 plus 1 is going to be an answer of 9. So we're going to put a 9. Wait, but that's in yellow. Let's see if we have something else. There we go. So we have 9 total diagonals. That's how many times lines can go across and touch another point without touching the point that's right next to where you started. But without having to put all this connect the lines stuff, how are we going to do that mathematically? Well, there's an actual formula that we're going to follow. And that formula is going to be the number of diagonals is going to equal the number of sides in parentheses, another number of sides. Then we have to subtract that by 3 because 3 sides of a triangle, and 3 for a triangle, it cannot have any diagonals because it's always breaking the rule. If I try to draw a triangle in the first place, you can't create diagonals because then there would have to be this or that as the legs. And the rule says that diagonals cannot be lines that touch the line that's next to them, that they're connecting. So that's why I have 3, because that's sort of like a baseline. Then we have to divide everything by 2. So let's see if we got this correct for number 9 with the hexagon. So we're going to say 6 sides, parentheses, 6 minus 3. Then we're going to divide by 2. So using order of operations, 6 minus 3 is going to be 2 times 6. That's going to be 12. So using order of operations, 6 minus 3 is going to be 3. And 6 times 3, because we bring this down here, it's going to be 18. And we still have that divisor by 2. So 18 divided by 2 is going to be 9. 9 is what we got for our answer when we used this formula right here. And that's what we got by drawing the answers manually on here. Now, let's see what the next question is. Let's try a challenge. So, going back to the formula, D equals m parentheses m minus 3 divided by 2. What happens if we try to find the diagonals of a 15-sided shape? We could draw them manually, however, it's going to take a lot of time, and it's going to be very, very boring, and this math video will be like longer than ever. Therefore, we're going to use this shortcut as this formula as a shortcut. So we're going to say the number of diagonals is going to equal 15, parentheses 15, minus 3 divided by 2. 15 minus 3 is going to be 12 times 15. That's going to equal 180. 180 divided by 2 is going to be 90. So in a 15-sided shape, if you ever wanted to do so, I would say break a leg, because it's 90 diagonals. Just imagine how many lines there would be. So, that concludes the video of diagonals of a polygon. I hope this video has helped you understand the diagonals of a polygon. Thank you for watching Top Penalized Math Industry. Like and subscribe.